Okay, this is third quarter study guide part 2. So on number 6, you're supposed to compare the rate of change for the two linear functions represented below. To compare the functions in a table, you use y2 minus y1 over x2 minus x1. So you pick 2 points like 0 and 2 and 3 and 4, and you plug them into that equation, y2 minus y1, to figure out what the slope is. Because when you're comparing the rate of change, you're actually comparing the slope. So you would do 4 minus 2 over 3 minus 0. So your slope would be 2/3 for function 1. Now when you find the slope for function 2, you're going to do this by counting. So when you find the slope of a graph, you count using what you know about rise over run, because that's slope. So you always start on the y-intercept, and you would find a point where they intersect the graph perfectly. So you would count 1, 2, 3, 4, so up 4, and over 1, 2, 3, 4, 5, 6, and over 6. And if you reduce these by dividing both by 2, you'd get 2 over 3. So your slope, or your rate of change for both of these, are the same. So both functions have the same rate. If you look at number 7, it says, what is the rate of change, which is the slope of the function graphed? So if you were trying to find out the slope for this one, you'd find out where they intersect perfectly, which is on the y-axis. And you would count 1, 2, 3, so up 3 over 1, 2, 3, 4. So the slope would be 3 over 4. For number 8, it says the table represents the linear function whose equation is c equals 15 plus 20x. It shows the total cost y, this is your x and y in the table, of renting a wallpaper hanger from a home improvement store for x days. What is the dependent variable in this situation? Dependent variable is always what y is. So the dependent variable would be the total cost. And number 9 asks, what is the equation represented below? To find out what the equation is, you have to write it in slope-intercept form, y equals mx plus b, where b is where it is on the y-intercept, which it is 2. And we have to figure out what our slope is, so we just count. So if we're going from 2 to wherever it intersects perfectly, which is also 2, if we go down 2 and over 2, 1, 2, that gives us our slope, because each time we're going down 2 over 2. So we can just represent that by saying -1, but when we fill in this into the slope for m, we only have to write negative. So this would be our equation for our line. Number 10 says, which equation represents the linear relationship between x and y shown in the table? When you have a table, you use the slope formula. You pick 2 points, and you plug them into the formula to figure out what the slope is. So we do y2 minus y1 over x2 minus x1. So it would do 1 minus 3 and 1 minus 0. 1 minus 3 would give us negative 2 over 1. And in this case, our y-intercept is easy to find because when x equals 0, okay, if they give us the information where x equals 0, whatever the y value is the y-intercept. So here, wherever x equals 0, it says that y is 3 when x equals 0, so we know that that's going to be our y-intercept. So our slope would be negative 2, and our y-intercept is 3. So our answer would be A. Number 11 says sketch a graph that does not represent a function. So an example of something that does not represent a function would be a graph that looks like this, where it does not pass the vertical line test. Because if I were to draw a vertical line through this, it would touch the line more than one place, so it does not represent a function. And number 12 says graph y equals 2x minus 1. So we have to graph 2x. So in this equation, the second number tells us where to start on the y, which is our y-intercept. In this case, it says start at negative 1. And from there, the number before x tells us where to move. That's our slope. So our slope is always a fraction, so if it says 2, it's really 2 over 1. So from the blue dot, I'm going to move up 1, 2 over 1. Up 1, 2 over 1. If I want some points below, I would just do the opposite of 2 over 1, which would be negative 2 over negative 1. So down 1, 2, and over 1. Down 1, 2, and over 1. And this would be my graph for 2x minus 1. And then for number 13, it says, which equation does not represent a linear function? And the answer is B. Because if it has an exponent, exponents are not linear.